Hello class, and welcome to lesson 4, greatest common factor. So your objective is I can find the greatest common, I don't want to do that. I can find the greatest common factor of two whole numbers by using the rainbow method. So we're going to be using the rainbow method. So last time in lesson 3, we were finding the least common multiple. Now you're finding the greatest common factor, or GCF. All right, jumping into vocab. Factor is a number that goes into another number. So for example, if you're looking at the number 3, the only factors that it has is 1 and 3, right? That's the only thing that can go into it. If you're looking at, let's say, if you're looking at 6, 1 can go into 6, and you multiply 1 by 6 to get 6. And 2 can go and multiply 2 by 3 to get 6. And that's all the factors. So these are the numbers, so your factors are the numbers that go into it. The numbers that can be multiplied together to get another value. All right, next is, I didn't highlight it. Next is greatest common factor, so it's our main word. The greatest factor that two numbers have in common. So if we're comparing, if we look at, let's just say the GCF of 12 and 18 is 6. So let's jump into why it is that with our unlock the problem, not steps. So, oh surprise, you're doing 12 and 18. So you know the answer already, but let's figure out why it's this. All right, so starting off with 12, I'm gonna list all the numbers that go into, or that can be multiplied to make 12. So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, 5 can't go into 12, neither can, well, I already have 6, 7 can't, 8, 9, 10, they all can't, so that's it. These are my factors of 12. These are the only numbers that can be multiplied out of all the numbers in the world. These are the only numbers besides, if you had a decimal number, that can be multiplied to make 12. All right, 18, we have 1 and 18, 2 and 9, 3 and 6. Can 4 go into 18? Nope. Can 5 go into 18? Nope. Can 6 go into 18? Nope. And then we're back. So we're back to 6. So those are all the factors that can go into 18. Now I'm going to highlight all the common multiples. So 1 is always in common, 2 is in common, 3 is in common, and 6. There's no 4. There is no 4 in the 18, and there's no 9 in the 12, and there's no 12 in 8 or either of them. So out of all of these that are common, the greatest common factor equals 6. All right, let's do steps so you can figure out what is she talking about. All right, step 1 is to list all the factors of the first value. So if our example was 12 and 18, we start with 12. And this is the rainbow method that I was talking about. So 12, and I like to do that so I know I'm defining 12. So I start with 1, and then I kind of do like a rainbow. All the way over here, I'm going to write 12. Because the only numbers, the last number is always going to be, because when you multiply anything by 1, it's itself, right? So it's going to be the last number. So it's going to be at the end, and 1 is where we begin. So our first one is connected to our last one. And then I know 2 can go into 12. And if I do the rainbow, 2 times 6 is 12. And then I have 3, can't really see, but that is yellow, times 4. And I can just stop here because I've run out. You start off by counting 1, 2, 3, 4, 5, 6, and I've already caught up because can 3 go in? Yeah. Can 4 go in? Yeah. Can 5? No. Can 6? Yes. Since I already did 1, 2, 3, 4, there's no other number that I know can go into 12 here because we already did 1, 2, 3, so no number is going to go between 6 and 12, right? So I'm done with that one. All right, so now step 2 is repeat for the second value. So we got 12 out of the way and we wrote all the multiples. Now we need to do the multiples, not the multiples, the factors. You gotta catch me if I mess up on that. So we're not finding the multiples because multiples are endless. You can have as many multiples as you need, but you only have a certain amount of factors that go into a number. So here we have 18. Okay, so I have 1 to 18. I know that 2 can be multiplied by 9 to get 18. So that's my second. What about 3? Can 3 go into 18? Yeah. 3 times 6 is 18. And can 4 go into 18? No. Can 5 go into 18? No. So can 6? Yeah, I'm already back here at 6. So I'm done. Once I reach a number that I already have, I know I'm done. So the only things you can multiply together to get 18 are 1, 2, 3, 6, 9, and 18. All right, step 3 is to circle/highlight all common factors. So just like last lesson where you have to circle all what you have in common, I still highly recommend you actually go through and circle/highlight because that's a time for you to reflect on your multiplication and make sure you got all the right factors in there. All right, so I'm always gonna have 1 in common, and I'm always gonna, well, not always, if it's an even number, 2 will be in common. I have 3 in common. I don't have 4, I don't have 5, I have 6, 9, 10, 11, 12, nope. So your step 4 is just, so your greatest value is the GCF. So as we can see, the GCF of, what do we work with? 12 and 18 is 6. All right, let's do some examples. All right, so starting with example 1, find the GCF of 36 and 27. So start with my first value. Rainbow method, so 1 can be multiplied by 36. The bigger the number, I kind of go a little bit farther because it's more likely to have more multiples. 2 can go into 36. How many times? Well, if you were to divide it, it would be 18. And that's our second, so that's our rainbow method. Can 3 go into 36? Yeah, 12 times. Can 4 go into 36? Yeah. 4 times 9 is 36. And can 5? Nope. Can 6 go into 36? Yes, it can. 6 times 6 is 36. Can 7? No. Can 8? No. So I'm done with 36. Now time to do 27. So 1 times 27 is 27. And 2 times, oh, 2 can't go into 27, can it? I always jump straight to 2. It's not an even number. But 3 can. 3 times 9 is 27. Can 4? No, because 4 times 7 is 28, so we're close. Can 5? Nope. Can 6? We have 24 and 30, so no. Can 7? You know, because it goes into 28. That's too close. Can 8? Nope. So this is our final for 27. And now I'm going to highlight all the ones we have in common, which is 1, 1, 3, 3. Luckily, there's not too many. 9 and 9. And therefore, the GCF is 9. Remember, we're looking for the greatest number. If we were looking for the least, everything would be 1, right? So that's how you can remember the difference between GCF and LCM. It's one of the ways. Example 2 is, well, find the GCF. I forgot to write that in. Find the GCF of 12 and 20. So 12 is 1 times 12 is 12. 2 times 6 is 12. And 3, yeah, 3 times 4. And I have, these numbers are right next to each other, so I know I'm done. All right, let's move on to 18. 18, woohoo, what problem am I working on? Let's move on to 20, there we go. All right, 1 times 20 is 20. 2 times 10 is 20. Can 3 go into 20? No, it goes into 21, so it wouldn't work. So can 3, 4? 4 can. 4 times 5. Oh, and we have another 2 numbers that end with each other. So we count 4, 5, so then we're done here. Because logistically, we would not be able to have any number higher than this, because otherwise it would have already been included, right? Therefore, let's highlight what we have. We have 1, 1, 2, 2, no 3, but we have 4. Close, but that's it. So the GCF is 4. All right, this is our third and final example, and it's a word problem. So Francisco teaches group lessons to all violin and viola students at the Scott School of Music. All of his classes have the same number of students. What is the greatest number of students he can have in each class? So we have this very pixelated, lovely table here from the online curriculum that I took a screenshot of. So it's, not the best quality, but we can see here that the instrument bass has 20 students playing it. Cello is 27, viola is 30, violin is 36. So we can just completely disregard the bass and the cello for this problem. We just focused on the viola and the violin. So we need to find the GCF because they're asking what's the greatest amount that he can have. So we have 30, and 1 times 30 is 30. 2 times 15 is 30. 3 times 10. Can 4 go into 30? No, we can go into 28. Can 5? Yeah, 5 times 6. And since these two are right next to each other, we go 1, 2, 3, 4, 5, 6. We know we are done. And next is 36. We have 1 times 36 is 36. 2 times 8. 3 can go into 36 12 times. Can 4 go into 36? Yes, 9 times. And 5 cannot, 6 can, because it's 6 times 6. And since we have two same numbers here, we honestly could just write 6 once, right? Because there's not 2 6s, but we know, I like to write it because I like to imagine this is being multiplied, this is being multiplied, this is being multiplied, this is being multiplied, and these two are being multiplied. But you could just write 1 6 if you'd like. All right, now, what do we have in common? 1, 1, 2, 2, 3, 3, no 4, no 5, we have 6, no 9, no 12, no 15. So we can see here that the I'm not going to say the GCF is 6 because it's not asking me what the GCF is. It's asking me what the greatest number of students he can have in each class. So I'm going to write that out and say, all right, so I just said the greatest number of students I should have wrote Francisco. That would have been more proper. Can have in each class is 6. And that's my final answer. All right, today's a little different for your independent work, so make sure you check Google Classroom for that.